Are we on? I think we're on. Okay. I think we're good now. I'm not sure what was happening there. It's the first time anything like this has ever happened. I was having issues just connecting to YouTube, and I tried to start my live stream twice, and I just got kicked out. But I think we're good now, and that's the important thing. So now we're officially back online. No need to worry. Welcome everyone to another daily dose of LeetCode, another live streaming for everyone out there trying to learn LeetCode for the first time. I know I've seen, I've been going around, I've been doing sort of like my own research, I guess, if you will, and I have been just trying to reach out to people who I know want to get better with LeetCode, want to be able to practice LeetCode. So I'm ecstatic about the growth that I've seen on this channel. We're sitting at 179 subscribers. I think for less than a month, that's pretty good. So I'm very excited to continue doing this. I'm looking forward to really reaching out to a lot more people, and I hope that you are all also finding it useful. Let me do something really quick. I want to open up the YouTube studio. I might do this one for a little more than an hour, so that's why I'm just taking some time here in the beginning to just take care of something really quick. So I know we have one live stream going. Let's see, this one's 27. Yeah, what I'm gonna do is I'm gonna delete some videos because I don't want people to get mixed up with what I actually have. Like what happened is if you go on the YouTube channel right now, you'll see that there's these two, or rather this one and this one. For some reason, these were just mistakes. Like YouTube was conking out, it wasn't allowing for me to go live. So I just want to remove these so people can focus on what's actually going on. Okay, sweet. So that looks better. So if you're here, if you're interested in this sort of thing, you want to see more live streaming, make sure you click on the subscribe. It turns out that a lot of people watching, there's more people watching that are not subscribers versus people that are subscribers. So if you're not a subscriber, you just landed here for the first time and this sort of thing interests you, remember to subscribe to the channel and also ring that notification bell because it really helps me out a lot and it makes it so that you always know when I'm live. So without further ado, let's go ahead and get started. So we left off at 130 questions yesterday, which I think is an awesome place to leave off. What we're going to do right now is we're going to do the usual. So we're going to click on algorithms. We're going to go to easy. And then we'll go to acceptance. And we'll go to, of course, page 2. We already finished page 1. At least the majority of them. Now we're going to start on this one, next greater element. So the title of this video is what's a monotonic stack anyway? You can see I was already sort of messing around with this before the stream even started. So a monotonic stack is a data structure that helps you keep some sorting order depending on the amount of elements you have. Or not really depending on the amount of elements, but given some elements, this helps you either have it monotonically increasing or monotonically decreasing. And for the purpose of this question, to be able to find the next greater element or the next, I guess if there's the next least element, I think there's some questions like that on LeetCode, but monotonic stack is really good for that. And let's try, and I haven't actually studied it in a long time, but let's see if we can sort of make sense of it ourselves and learn from it. So really what I want to take are these numbers right here, my 1, 3, 4, 2, because I believe not all the numbers in the input, but at least some of them are represented inside of this array, right? We have the 4, the 1, and the 2. Here we have a 4, we have a 1, and we have a 2. So how can we create a monotonic stack out of this? Let's create a monotonic, I guess, monotonically decreasing stack. And what that's going to do is we want to, because we want to find the next greatest thing, we want to create a stack that's actually in decreasing order. Anytime we find an element that's larger than its previous one, that's going to mess up the order, right? So that's going to give us an indication of I might be larger than my previous elements, and this is going to be sort of how we key off and then use this to our advantage. So imagine we start at the 1, right? Ideally, if I want to keep this monotonically decreasing, I would want the next number to be lower than 1 or less than 1, strictly less than 1. I think for the purposes of monotonically decreasing array, it should be strictly decreasing. So we put the 3, right? And at this moment, we ask ourselves, well, 3 is not less than 1, so we're going to have to pop off previous elements until we get to a point where this one is smaller than its previous, or we are sort of sitting at an empty stack, right? So I say, let's pop off 1. There's nothing prior to 3 I can look at anymore, right? I'm already at my empty stack, so now I just leave 3 as is. But what do we know based on that? we know that 3 is 1's greatest or next greatest element. So let's say over here we put 1 to 3, right? It's sort of this mapping I'm creating. Then let's keep pushing from here. We say, okay, after 3 comes 4. Okay, that's cool. That's fine, right? Actually, no, wait, I'm sorry. That's not fine. We want to get the next greatest element, right? So ideally we want something that's less than 3 because we want our stack to be decreasing. 4 is not. So again, we pop 3 off. And now we leave 4 here and we say, well, for 3's next greater is 4, right? And now we have 2 and that's fine. Now, what does it mean? We were able to find 1 and 3's next greatest elements, and for anything that's still left inside of this monotonic array, it means that there is no next greatest element, right? 4, there's nothing to the right of 4 that's greater. There's nothing to the right of 2 that's greater. So that's essentially the answer there. So by using this monotonically decreasing array, we're able to retain the order, right? The decreasing order. And then anytime we find a new number that breaks that ordering, we can start to look at previous numbers, and in that search we'll find which one the new one is greater than. So I know that maybe all sounds crazy, so let's see if we can think of a way of doing this question with the monotonic stack. I think what we can do to make this pretty fast, right? I think one thing I would like to do is I would like to keep track. I would like to know the indices of each one of these numbers, right? Because that means anytime I find a number that is greater than any one of these, I know exactly where it lives and I can just modify it immediately. So I think that's one thing I'm going to want to do. So because of that, what we could do is, let's say const index map, we'll make this equal to an object literal. We'll say for let I equals to 0, I less than nums at 1 dot length, not nums at 1, just nums 1 dot length. We'll do I plus plus. Here we can say index map at I equals nums of 1 at I, right? So index map of 0 will equal to nums 1 of 0, which is 4. So we know that at index 0 is 4. Now, is that actually as helpful? No. I think really what I should do is I should say that the index map of nums at I equals I. That way I know that, for example, 4 is in position 0. Now, one thing that we know is these are all distinct. That's something else that really helps us out here. So now that we have this index map, we can start sort of working on this monotonic stack, right? So let's create our stack. And what is it we want to do now? Now I want to operate now on nums2. So I don't even think that we need to get, I don't think I need to keep track of indices. So because of this, I might do for const style of loop. Now, here's an interesting thing, right? There's this sort of principle in software engineering that you should try and remain consistent. Like if you're going to pick one way of doing things, stick with that way. So even though like in this case, I don't need indices, I might actually choose to stick with this style of for loop because it just actually is easier to read. They're both the same style of for loop, and that I think just makes for more readable code. So we're going to go ahead and actually do that. This time, however, we're going to be going through nums2.length, I++. Now let's think about it, right? If like while anytime, well, we know we're going to push some number in here, right? So say stack.push nums2 of I. But before we do that, let's say we're going through our example again, right? Nums2 of I is 1. We want the next thing to be less than. So here we can say while stack, right? While stack.length is greater than 0 and nums of I, or nums2 of I, which is the, let's see, the 3 is greater than nums of 2 at I. While nums of 2 at I is greater than stack at stack.length minus 1, right? What is it that we want to do? We want to pop off the stack. Stack.pop. So let's sort of run through this really quick and see exactly what we're doing. So we have nums2, which is 1342. This is going to be where our I variable is right here. And let's imagine right under here we have our stack, right? So now we're going to say for let I equals 0, I less than nums2.length I++. We say while stack.length is greater than 0. So already this is false, right? So we're not even going to enter in here. So let's just go ahead and put 1. Now we get to the next one. While stack.length is greater than 0 and nums2 of I, right, which is now 3, is greater than stack.length. It is greater. So right now we want to pop. Now, when we pop, we're going to get a number. So we're going to get like 1, for example. So let's actually get const popped value equals stack.pop. What is stack.pop going to give me? 1. Right? Now I already have this index map that's going to contain 1 and the index it's in, which is 1. So what I could do is I can get const index. I can go inside of my index map, get the index of popped value, right? And now inside of nums1 of index, we should actually enter in nums2 of I, right? So let's go over that really quickly and let's look at what exactly we just did. Remember, this is nums2 right here. Let's now write out nums1. Okay. And let's even draw our little map here. So 4 is to 0, 1 is to 1, and 2 is to 2, right? Let's check this out. Const popped value equals stack.pop. So we pop off this stack. Stacked value is popped value is 1, right? Now the index is index map of 1. Index map of 1 is 1. So now I go to nums1 at 1 and I replace it with nums2 at I, the element that we just did this whole logic for, the one that we know it's bigger, and nums2 of I is 3, right? So you can imagine at this point we sort of have something that looks like this. And if you look at our output, that's exactly what we're starting to get. So if we're gonna do this in place, right? That's what I'm trying to do here. We're gonna do this in place. Okay. And now at the end, in our stack, the stack we had before, now we just push 3, right? Because that's gonna be what we have at the end. Now we get to the next thing. We go to increase I. While stack.length is greater than 0, which it is, and nums2 of I is greater than stack.length minus 1, right? Now this should be, if it's greater than, we want it to be decreasing. So because it's greater, the one after 3 is 4. Oh, but we don't even have a 4 in there. So now we also have to make sure that the value exists inside of here, right? Because although we did find a greater element for 3, which is 4. 4 doesn't actually exist inside of our map. Or rather, 3 doesn't exist inside of our map. Right? So we get to this point and we say, okay, this is greater. So now we can pop it. Popped value is 3. Do I have an index in here? So only if we can say index map of index is not equal to undefined, then we can do the thing, right? So we'll still pop, right? We'll still, oh, I think I lost a little bit more than I wanted, right? We'll still pop because we no longer care about that 3 because 4 is bigger, but we'll only do this if we find the 3 index map of index. How did I get this index? We want to get 3, right? Yeah. So this should actually be popped value. Only if index map at popped value is undefined, then we can go ahead and do this piece, right? And then at the end, this is empty. So now we just push 4. Then we get to the next piece. While stack.length, right? We increase this. While stack.length greater than 0, nums2 of I is greater. It's not. So we just push, and now we're out of bounds. Now, what is it that we have at the end now? We have a 4 and a 2. These are 2 elements that do not have next greater elements, right? But what do we do have? We still have this index map, and now we know that for each one of these we can just enter a -1, right? So now we can say for let I equals 0, I less than stack.length, I plus plus. I want to get the index of the current number. Const index is index map of stack at I, right? So stack of I is 4. Stack of 0 is 4, and the index map of 4 is 0, right? So now here I can say nums1 of index is equal to -1, right? Because that's what I know. I know that any that doesn't have a next greater element, according to this, they want it to have -1. And then finally, we can just return nums of 1. So let me remove all this. Let me remove this piece. And now let's go ahead and run this and see what we get. So -1, 3, and 1. Let's go ahead and do all of our different test cases. 3 and -1. Okay, let's go ahead and run it. Okay, 66.9. That's pretty good. I'm pretty happy with this. So, very important question to know. I think there's going to be a medium question that we'll get to in months, since we're doing every single easy question. Probably take 2 months from now at this rate, I'd say. There's one about finding the next greatest temperature or the next lowest temperature. Now, something very interesting to take note of. I believe, so this, the bounds of this question, we're only ever going to get to 1,000 items. I think that the medium one, although it's a similar technique, we need to figure out a more optimal way of solving it, because, you know, every single time we do this backtracking, it takes time, right? Let's see what we have at the end. So based on what I'm seeing, since I had 2 68s and a 13, there's almost certainly a faster solution to this. 34.91. Is there any place that we can do better here? Let's think about this. I'm saving times. This, you know, with this index map, I'll sort of get that constant access. Well, let's do our own. Let's do the. Let's see. This is O of n plus O of n, right? Now this piece right here, nums2 of I greater. I mean, this is going to incur some time complexity. Is it bigger than us going through the whole thing? I'm not sure. But what else can we do in here? Do we need to find? Do I need to do this piece right here? The stack. I feel like I need the stack. I feel like it's good to have this index mapping here, but maybe because, oh, I don't want to look at discuss. Maybe because, like, what if I just create 412, 1342. Hopefully you guys don't hear my dog too much. Let's see what discussions have to say. Just like, so C++ stack plus unordered map. Okay, right, we did use a stack and we did use an unordered map. Stack and dictionary, time complexity O of n with explanation. So this sounds similar to what we did, right? S.pop while S for ent answer.pushback. So like, let's actually try something here, right? It looks like just at a high level, maybe they're not taking care of const popped value stack.pop at the end. 4.3 at the end, we're just gonna have numbers. Yeah, I'm only gonna have the numbers that were not, that don't have any greatest. Okay. See more in my GitHub repo. S.size and S.top, same thing we did. M of S.top equals N, S.pop. Now this part right here, M equals N, S.pop, count or -1. So if it's actually in there. I need to revisit this one a little bit later, but I'm happy with what we did here, and the reason being we figured out the monotonic stack, and well, look at this, I guess 96.47, not too bad after all. We were able to figure out the answer. So that's really what it is. When you're trying to find elements to like your right or even left, you can maybe as homework, you can figure out how to do it to your left. The monotonic stack is going to be very helpful. So I'm happy with this. Let's go ahead and continue to this next one. So remove all adjacent duplicates in a string. I really like this question. This is a phenomenal question. Let me go back and like this question here. I'm going to also add it to my list. Very important to know. This one's so good. So you're given a string S consisting of lowercase English letters. A duplicate removal consists of choosing 2 adjacent and equal letters and removing them. So, oh, hey, look at that. It's a new face. Minaj. I hope I'm pronouncing that right. Minaj. Thanks so much for joining. It's nice to see a new face around here. I'm a little bit sad that I haven't seen Rashawn. Rashawn was always coming around, but I'm really happy to see a new face around here. I really hope that you are enjoying these streams. I hope these are beneficial. You know, this is sort of like a different take on the whole LeetCode grind, right? Maybe this is sort of like almost a LeetCode podcast, so to speak, maybe. But I just hope it sort of relaxes you. Like, we're still learning, but we're doing so in a more relaxed manner, so it's not as, grindy, I suppose. But yeah, thanks a lot for joining. Love to have you here. And let's go ahead and think about this. So anytime I would see a string question, especially in JavaScript, so in JavaScript, strings are immutable, and anytime I would see a string question, I always thought that I had to make, anytime I saw about deletions, or removal in strings, I thought they expected for me to use a method like splice, for example, and actually remove characters from a string, which can be a little bit complicated, right? But really, you should think about this in a different way. The way I think about this now, after having not thought about it this way for a long time, is you can sort of dynamically, we're going to be creating a new string that does not include the things that we don't want, if that makes any sense. Instead of thinking about removing things in the string, think about creating a new string. Like, we're going to be creating the final string instead of removing things from this one to get there, if that makes any sense at all. Let me show you what I think. Right, exactly. I'm guessing you will make a new string. Yes, that's exactly it. And it took me a while to think of it from that perspective, because I would, like I said, I thought I had to actually remove things from here. So there's a very similar pattern here, and I guess the pattern here is like, and I'm not even sure if this is what it is, but if you've done questions like balance parentheses or anything that has to do with like parsing a string, you might know that the, what do you call it, like a stack is really good to be able to do this, right? So you said here you loop over the string and you skip over duplicates. So let's think about that. So if I go to A, so like, do I only count, can we return it in any order? Are they allowing for me to return it in after such removals have been made? That's maybe one way that we can do it. I suppose we'll need to keep doing it as long as there aren't any duplicates. But let's sort of start building this out and see what happens. So imagine we have A, B, B, A, C, A, right? Imagine we're building the string and we say, okay, the first thing in my string is A, right? The next thing in my string is B. Now, anytime I push, you can sort of ask yourself, like, when I push, as long as my stack is greater than 0, I can check to see if this new thing, or even before I push B, for example, right? I can say, is the top of my stack B? No, it's not, so I can push it. Now I get to another B. Now I ask, is the top of my stack B? It is. So let's just go ahead and pop that, right? Because if I were to push B again, I'd have duplicates. Now I get to the next one. And let me do like what I always do here and put my pointer, this I variable, so you know where I'm at. So let's start again. I push A. I say if my stack is empty, then I just push. Now I get to the next one. Stack is not empty, so I say, is the top of my stack currently equal to the character I'm on? No, it's not, so I can push. I get to the next character. Is the top of my stack equal to the thing I'm currently on? Yes, it is, so let's push or pop from the stack. Now we go to the next one. Is the top of my stack equal to the thing I'm currently on? Yeah, it is. We pop the stack. Now we go to the next one. This is empty, so we just push. And now we get to the next one. Is the top of my stack equal to what I'm currently on? No, it's not, so we push. And now you finally get this at the end. So it's a very different perspective, because like I said, the first time I saw this question, I probably tried to like loop through it a couple of times. And anytime I found a duplicate pair, I might use something like splice to literally remove that pair, right? So you might think to yourself like, yeah, and that's really like the aha moment, like when you start using a stack. Because if you think about it, like it's very similar to that balance parentheses problem, right? Like anytime we're about to push a new parentheses, we like check the previous one. If you almost think of these are not duplicates per se, but they're the same style, right? It almost falls into the same bucket as duplicates. So, for example, in the first way, I might have done like, okay, A, B, B, A, C, A, I'm looping through this. And maybe if I have like my I variable here, I tell myself, okay, this one is equal to the previous one. So like, okay, remove these. But now I just remove those. Like, remember, here we were like I equals 2. Now I remove these, and now we're still at equals 2. There's no duplicates. This thing goes all the way, right? And maybe I'll have a flag that says like, did I find a duplicate, right? I did find a duplicate. Now I got to check again, right? So maybe I get to this point, start here, I start here. Okay, I do splice again. Now I'm at the end and I go, right? I check one last time and now there's nothing, so I'm done. So that would require me going through the entire string 3 times in this case. And you can imagine for strings that are really long, it might actually incur like a big performance hit there. So let's go ahead and start constructing this, and let's come out with it. So I'm gonna say deduped. So deduped, I think it's just like unique, really. Or let's actually see like, or deduplicated. It's something I see in like logging software all the time, to dedupe some amount of logs to only get the unique ones. So deduped is gonna be where we hold our final string. So let's do for const c of s. Now we can just start doing this, right? So anytime that it's empty, we can just push. So we can say if deduped.length is equal to 0, we can say deduped.push is equal to c. Else, right, we can say if c is equal to deduped is equal to the top thing dot length minus 1, then we say deduped dot push c. Sorry, my dog's barking and there's someone in front, but I'm not sure if I'm supposed to go. Okay, no, it's fine. The postman knocked, but everything's good. Hey Raphael, I hope you and your family are doing well. Hey Rashawn, I was just talking to you. I was just talking about you because I'm like, oh, I haven't seen Rashawn in a couple days. You know, I think it's been a day, but it's good to have you back. I hope you and your family are doing well as well. And yeah, glad to have you around. We have a new face around here, Minaj. So now it's cool. We have 2 people. This is awesome. Let's keep it up. So, right, like if C is equal to the previous one, then we pop it, and at the end we just push. So let's think about this, because we can actually, we might be able to let me see if there's a situation where we actually get into some like loop. Let's try this one right here. Right, so this is empty, so I push, I come to the next thing, which let's say it's I, right, it's not empty. I say if C is equal to here, I wouldn't push, right, I would actually pop. Let's just get that down, right? If C is equal to no, but see, we never got a chance to push, so for now I'll put this down here. But I'm aware that like there could be some duplication here. I think what we can do is, it doesn't really matter if it's empty or not. We'll just have to make sure that we pop if it's equal. So I think what I can do is just once, I can say if deduped dot length is equal to or greater than 0, and C is equal to this last one, then we can do deduped.pop, and then here we just have deduped.push. I think this is a little better here. I think this will make a lot more sense. Let's go over this now, and we'll just start again from the beginning because I think it's good. Okay, so if deduped.length is greater than 0, which is not, so we just go straight to the push. Next one, it's greater than 0, but Z is not equal to A, so now we just push this. Go to the next one. Greater than 0, but X is not equal to Z, so we push this one. Here, greater than 0, X is the same as the previous one, so we pop. And now we don't see, like, I don't want to push, right? That would be, yeah, that wouldn't be good. I really just want to get to the next one. Like, I should just immediately go to the next thing and then do that. So we could say, I suppose here we can have our if and else. So for here, let's just get to where we were before. Let's sort of like backtrack. We had the X. Here, deduped is greater and they're the same, so we just pop. Now we go to the next one. They're the same, so we pop. Go to the next one. They're not the same, so we push. And we end with AY. Let's also do the same for this one right here. Let's just start this whole thing over again. Okay, it's if dedupe, okay, it's not greater than 0, so we just immediately push. Greater than 0, but not the same, so we push. Greater than 0 and they are the same, so we pop. Greater than 0 and they are the same, so we pop. Not greater than 0, so we push. Greater than 0 and they're not the same, so we push. And then we end up with CA. So then at the end, we'll just have to return. And you know what? Can we, let me see something. We can do return deduped.join, right? Because we're gonna have to join this. Let me run both of my test cases here. CAAY. Yeah, great question. So I would imagine dedupe.length is O of 1 because if we like create, so dot length is just an object. It's just a property on this string, on this array object, right? So like if I do like const deduped, set this equal to that, and I do console.dir deduped. Is this, no, this won't show me. Oh yeah, there you go. Like we just have this length property right here. That's just like an object, right? We get that value back in constant time. Good question though. So now this gives us that. Let's submit this, and then I want to try something else. Let's see what this gives us. All right, 89.39. That's pretty neat. Now let me just remind myself if string pop, string slice array pop. I don't think there's a way for me to remove. Yeah, I was almost thinking of just using straight up string concatenation. Or I wonder if I can just remove the last thing. Index start, index end. This might actually make things a little bit weirder. Like having to use slice to remove the last thing might look kind of strange. So I think it's actually better that we use this right here. And if you want, we can make this. It won't really save too much on lines, but I know some people love ternary statements. So we could just do this. I know people love this stuff. We could just remove all that. We're left with this. Let's run this again. Did I misspell something here? Oh wait. Oh man, that's gonna cause my acceptance rate to go down. I think. I don't know if like syntax errors cause it to go down because it wasn't wrong. Nice. Sweet. So yeah, this is a very, very good question too. Like I know like stacks in general are good for parsing strings. And I think if we go, there's a website called like Sean Prashad LeetCode Patterns. Sean Prashad LeetCode Patterns. He has like tips here, and I think one of these, if recursion is banned, then stack, permutations, given a graph, linked list, in place, map, sort, input. Okay, he doesn't have, I read somewhere though where using a stack is good for string parsing. So here, again, similar to how we had, like we would do parsing for the balanced parentheses problem, it's very similar here. We're parsing this string, and the stack helps us do that. So I'm gonna like this question. I'm gonna add it to my list. Let me quickly talk about this list real quick. If you at the end of the video or at the end of the stream, whenever we decide to finish, what I've been doing is on all my different videos, you'll notice that there is a list of questions that I put down here. So it says here's a list of questions I recommend practicing. You can actually click on this list, and this is a list just like you might think about the LeetCode 150 or Grind 75. I might organize this better later on, but these are some of the lists. These are some of the questions that I've worked on since I've worked on all the questions so far that I have found particularly useful. So it could be helpful for you as well, for people watching, to go through just another list. This one's a little bit different again because it's not as focused as some of your other ones. It's just more of a general list of questions that I have found particularly useful to understand. Yeah, that website is called Sean Prashad LeetCode Patterns. I would say it's probably like the most beginner-friendly website to start getting into this stuff. This is more in line with, your Grind 75 website or your LeetCode 75 study plan, Blind 75, because it's a very focused list of questions to do. It's really nice if you're on like a shorter timeline. If you want to get from 0 to hero, you have an interview coming up, in a month, you want to do something really quick. This one's a little bit more beginner friendly, and it's phenomenal. You get some nice tips. You get some nice like company tags here. You get, the questions, you have solutions. So, and even the patterns are very helpful as well. So I can actually link to that. I'll link to that on the YouTube chat right here. And if you guys want to check it out, just feel free to check it out. Like I said, my streams are more casual. My, the intent, if you guys saw like my channel intro, my intent is not really to teach LeetCode. It's more of just for the viewers to watch someone go through it, perhaps for the first time, and just see what are the things that person's thinking about to try and get through. So with that being said, let's get to the next one. Sort array by Parity, number 2. All right. Another great question. So 3 high quality questions in a row. That's really cool. Let me get a sip of water real quick. All right. Given an array of integers and nums, half of the integers and nums are odd, and the other half are even. Sort the array so that whenever nums I is odd, and whenever nums I is even. Return any answer array that satisfies this condition. So we need to put, I think I might have an idea of how to do this. So 4, 2, 5, 7, we have, right, like we have some indices that are even, which I'm going to denote with E, and we have some indices that are odd, which I'm going to denote with O. So we always want to swap. It says, what is it? Like in each even one, there should be an even number. So like 4 is fine here, but here we should put the 2. So we should just be able to swap these, and that's going to satisfy that, right? If I put 5 here and 2 here, then we get exactly what it wants. 4, 5, 2, 7. Okay. So return any array that satisfies this. What's like a nice way for us to do this here? Like I know anytime I get to like my even, I want to ask, I'm asking myself, let me get the next even and just place it in this spot. Now, I wonder if I can use, the question is weird, laugh out loud. At least it's not ordered. Yeah. Right? Can we, if we were to order it, could that help? I guess not really, right? Because it could still mean that an odd number is in the first position, which would be 0. But that's a good thing to think of though, like sorting for sure. I think that's definitely, that's almost like one of the first things you think about in an array problem, at least for these easy ones. We're probably going to learn better patterns as we keep going along, especially when we get to medium questions. So we want to do this like in order sort here. I mean, we could, it doesn't sound great, but I could create 2 stacks of even and odd, and anytime I get to an even or odd index, just pull from each one of those. But that would require for me to create 2 new data structures, right? 2 other arrays that keep this information. But it would be nice if, like, imagine we're here at I, and I say, okay, I is 0, so this is an even one, and an even one is here, so that's cool. Now I get to 5. This is odd. Oh wait, this is the answer. Yeah, 4, 2, 5, 7. So I say, okay, like, I don't want this to be there. What if we instead, you can have a variable where it is the last even and the last odd index. I was almost thinking of, like, that maybe could work. But what if we had a variable called like let even equals 0 and let odd equals 1? So you said you can have a variable where is the last one you're looping through, if that makes sense. You can have a variable where is the last even and the last odd index. Right. The only thing is that for me to get that information, I'd have to start in the end, right? And start going, because you're just looking for last odd index. I'd have to go and find where, I think that's what you mean. Like I'd have to find where an even number sits and an odd number sits, and those can actually be all the way in the beginning. So I'm having to go from the back all the way to the front. I think maybe, like I know that, like as soon as I fill in spot 0, then I can just immediately go to spot 2, spot 4, right? Because these are going to be even indices. Same with here, I can start at 1, 3, and 5. So what if we just did, let me see how that might work. So if I found, see, but this might introduce, oh, let's see. I'm at an even now, and the next time I find, or whenever I find an even, I just put it in the even index. So I already did that, so let's just make this 2, and we'll leave this as 1. I found, let's see, I found an I here. This is even, but I is 1, so this should go in the next even index. So maybe I should swap. So let me put 2 where it should go in 2. So that's cool. I can make this 4 immediately, and I'll put my 5 here. And that's okay there. I get to the next one. I is 2. So now in here, should I do anything with... Maybe this should stay as 2. And now odd should be 3. 4, 5, 2, 7. This is a very contrived example, so we need to expand this a little more. Now, I mean, when you're looping through 4, 2, 5, 7, when you hit 5, the last even would be at index 1, so you swap it. 4, 2, 5, 7. The last even would be at index 1, so you swap it. I think I get what you're saying. So you can use mod. I just realized. Oh, maybe I wonder if like maybe your solution was like for another type of question. But let's see what we have here. Could you solve it? Oh, okay. So in place. Okay, so we're trying to solve it in the in place one. So I guess doing the thing where you have different. I mean, I can just store all my, yeah, I mean, let's do a brute force, right? So at least we get something out. Const even, const odd. For let I equals 0, or we can just do, yeah, let's do for let I equals 0, I less than nums dot length, I plus plus. If nums of I modulo 2 is 0, right? This is an even number. So we just say even dot push nums of I, else odd dot push nums of I. All right, if it's even, push into even. If not, so now what we can do is we can say, we can loop through this for let I equals 0, I less than nums dot length, I plus plus, and we can just say if I modulo 2 equals 0. So if it's even, we can say nums of I is equal to even dot pop. Else nums of I is equal to odd dot pop. Return nums. I think this is one way to do it. But it's not, I mean, look how long it's taking. 2745. I think they said that's okay. You can see, I mean, it looked like it was taking long. Now, of course, this is, we want to do the follow-up, right? I just wanted to validate that theory I had. Let's run this and see. Yeah, I know it's going to run slow. Okay, that's crazy. I literally said it's going to run slow, and then it runs like faster than almost any other algorithm I've done. But I don't, this is not, I wouldn't say this is the way of going about it. I wouldn't say this is the way of going about it. There's definitely a better way of doing this, and it's continually doing well. But let's see. Can we do it in place without creating anything else? Yeah, no, same. I literally am also, I'm so surprised. I'm like, there's no way this can, because we're creating 2 new arrays, right? So let's try to go back and figure it in place. So there's one of these that's in, like, sort array by parity number 1 is easy because it's just all odds, or all evens on the left, all odds on the right, right? So that's like a simple thing to figure out. So let's see if we can figure out this other way though. Anytime, like, would a 2-pointer, could 2 pointers help me out here? Or like, I just need to find, anytime I find one, let's think about this, 4, 2, 5, 7. 4, 2, 5, and 7. I'm gonna comment all this out, and I'm just gonna move this to the top up here. Okay, 4, 2, 5, 7. Kind of reminds me of bubble sort, but instead of greater or less than, you check if the parity matches the index. Yeah, we could probably also bubble it up by parity. That makes sense. I can see that being a thing. Although I'm not sure. I don't know what the best runtime is, but bubble sort's quadratic, right? If I remember correctly. So I think if we did it that way, it might actually end up being worse than this, because this right here would just be O of n. But I think that you can also do that as well, though. I'd be curious to try that out at some point. So what if here we had, what if I just found the first even index and the first odd index? Like, what does this tell me here? Are both of these the same? Or are they both where they should be? They are both where they should be. So maybe now I increase, I go to the next one here, and then I go to the next odd, which is here. These are not in place. So do I swap? Now what happens if both are odd, right? Like what if this is a 9? What do I do here? 4, 9, 5, 7. Wait, will that ever be the case though? There's always going to be 2 of each, right? Like here we wouldn't have 3 odds. Now let me think about that. Why would that work? I can do odds and evens. On my left, I'm finding odd or evens. On my right, I'm finding odds. I go to where they should be, and I check. Let's come up with like something else. Let's do 8, 7, 6, 5, 4, 3, 2, 1. Right? Because this is even, odd, 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 odd. Let's figure that out. So even in the beginning, and odd. Oh, but this is literally this is gonna work fine, because this is also a bad example, because here these are fine. It's where they should be. Go to the next one. Yeah, I think we need to do like 8, 4, 3, 1, 2, 5, 7, 1, 2, 3, 4, 5, and then a 6, 7, 8. Let's try something like this. So we're at even in the beginning, because this is 0, right? And then odd, 0, 1, 2, 3, 4, 5, 6, 7. So odd will be here. Now, even, so like this is not where it should be. Odd is not where it should be. These are both even numbers. Or maybe instead of 2 pointers, any single time that I'm at, if I start at 0 and then I go to 2, if that's not odd, how do I know where there's another even one? Or maybe we can also say, maybe I can do something similar to like the first parity, where this becomes my index, and now I'm, let's say like at J, this is 0, so that's fine. So now we go up here. Now I need to look for an odd number, so we swap these. Okay, because that's odd. 3 and 4. Now I need to look for an even number, but that's already an even number. So maybe I continue. Now I need to look for an odd. That's already an odd, so I continue here. But I also want to make sure this is also continuing along. Maybe that could work. What about test case 2, 4, 6, 1, 3, 5? Yeah, we can try this one out too. 2, 4, 6, 1, 3, 5. I almost think that might work. Like, if I have an index here, and let's say I have a J here, like this index, it's like J is what's going to traverse my array. index is just helping me decide where I place a value. So if I is even, then j should find an even number. So let me take some notes here. If I is even, j should look for even number. If I is odd, same thing, right? Or, well, should look for odd number. I'm just sort of thinking out loud here. So I is even, j looks for an even number. Well, it's fine already. Now I is odd, so j should look for an odd. So we say, okay, we're here. Let's look for an odd number. And now we swap these because we found an odd. So let's say this is 1 and this is 4. We increase I. I is even. I is even, but the number it's currently on is also even. So just keep going. I is even. So I is even. Keep increasing I if nums of I is even, else j should look for even, right? I is even, so now we come here. I is odd, so j should find an odd, which is here. This is 3 and 4. I is odd here, so let's go now. I is even, that's already even. I is odd, that's already odd, and now we're out. So I almost think maybe that could work. I just need to get that in my, oh man, what? Okay, I just heard some sirens. I need to like figure out the algorithm a little better, but I think we're onto something here. I'm gonna use that same test case again, Manoj. So 2, 4, 6, 1, 3, 5. So start making some variables. I'm gonna say let index equals 0, let runner equals 0. So we have an index and we have a runner. Okay, so if I is even, I is already even, so we should keep going. So I think I'm gonna do something like, let's see. Keep increasing if nums of I. Okay, so I is even, so that's good. We can get to the next one. I is odd, so now j should find an odd number. And then when it starts doing that, okay, j should find odd number or j should find an even number, depending on what the value of I is. But these are not going to be moving. These are going to be moving at different times. So we can say maybe while index is less than nums.length and runner is less than nums.length. Perhaps here we should do, let's see, while, I might have like 2 while loops here. Like while I, and it wants us to do, yeah, I think we can always start at even because I is, yeah, while I modulo 2 is equal to 0, let's think about this. We want to keep going if it always matches. So if, yeah, I think we're on something here. I'm just having some difficulty like putting this in code, but I think any single time I just check, but how do I, so like if, like I know to stop here because I is odd and this is even. Is there a way that I can write that just like in a single line? Or maybe we'll just say if I modulo 2 is 0, if I is even, and if I modulo 2 equals 0, and nums of I modulo 2 equals 0, then we should do I++, or index++. I keep doing I. Should be index. That's going to really make this part long here. But then the same thing for the other one, right? So I'm just writing these both out so I can see if there's a way that I can make this better. Oh wait, this should be modulo 2 is equal to 1, modulo 2 is equal to 1, index plus plus. But if it's not, look for the next one. Oh, I feel like we're so close here. It's just that one piece. Or, I mean, maybe that's an optimization. Let me make it more like brute forcey. So I just say if index, okay, if index modulo 2, if index modulo 2 is 0, right, then J needs to find, right, runner should find an even number. I can say while nums of runner modulo 2 not equal to 0, runner plus plus. Right, so index modulo 2 is 0, while nums of runner modulo 2 is not equal to 0, which it is 0 here. We can just like essentially swap these, right? I mean, it's sort of like redundant, but that's okay. So here, what if we just do, there's sort of some weird syntax, but it works. Like we can say nums of index, nums of runner, and this will be equal to, I think we can just remove these at the end. No, I think I also need to have those inside of a larger array. Nums of index equals, this will be nums of runner, nums index. I know that looks crazy, but I assure you it works. There you go, just this one here. This just will do a swap. And I think here now we should increment index. And then here we can do the same thing. I think we'll figure it out. If index modulo 2 is 1 is not equal to 1, runner plus plus, swap them, index plus plus. Let's see what this does. Why do you have that runner condition? That's what I'm gonna go over right now to see if any of this is even making sense. While loop. So let's see. So index, we have index and runner, right? Let's remove, well, I'll leave that down there. This is fun. This is like really where we're going to be doing a lot of the learning. So while index is less than nums.length and runner is less than nums.length, if index modulo 2 is 0, right? So index modulo 2 is even, while nums of runner modulo 2 is not equal to 0. It is 0, so we're never going to increase runner. We're going to swap these. We're going to swap the thing at nums index and nums runner. So it's essentially just going to stay the same, and now index is going to go up. Now index modulo 2 equals 1. So now we say while nums of runner modulo 2 is not equal to 1. Right, so that's 0 because it's not equal to 1. This is equals to 0, not equal to 1. So now here it is equal to 1, so we stop. And now we swap the thing at index and the thing at runner. So this should now be 6 and 4, and we increment I. Now it's even. While nums of runner modulo 2 is not equal to 0, runner plus plus, it is. So we just do the swap, which is the same thing again. We get to the next one. Now it's odd. And now we find an odd one, so it'll be here. We swap, it's the same. We get over here. All right, this is also now 135. Oh wait, did we miss? Did the one that you have 246 135? 264. This should be even. I feel like I messed up somewhere over here. 264 135. I think I left these 246 135. Okay, I'm gonna have to start this part over again. 246 135. Close. I thought we were close. Let's see. Let's try this over again. Index modulo 2 is 0. So it's even, so we should find an even number. We found our even number. So now let's go to the next one. This is odd. Okay, that's why. This is odd, so I got to find an odd number, which is here. And now I do the swap. I put a 1 here, and I put a 4 here. So this is an even. You see, but that's the thing. It's already an even, so I shouldn't do anything if it's already an even. If index modulo 2, like I don't think runner should look for anything, because here it's even and I'm saying, okay, runner find an even, which I guess we did. Well, let's see what happens anyway. We do a 4 and a 6. This is odd, so let's find an odd, which becomes here. Now we swap these 3 and 6. This is now even, so let's find an even. We don't find an even, we go outside, but everything's already been put in its place. So I think this could work, but maybe I'm doing unnecessary swaps. So let's try this out. I'm gonna comment this stuff out. I'm gonna comment this out. And let's return nums. Let's see if that swapping worked, because the swapping thing is always like weird. Let's see. 4, 5, 2, 7, and 2, 3. All right. Oh wait, I think I ran the test again. 2, 3. Okay, let's do this. Is it gonna work? Wow, how is that slower? Like, what? I think, okay, there's definitely, I shouldn't do a swap. If index modulo 2, I don't think I need to find, like I don't need runner to do anything if it's already good. So if nums at index modulo 2 equals 0, then break. Let me see if doing anything like this will work. I'm gonna try to run this. I might regret this and my acceptance rate will go down. Okay, 4, 2, 5, 7, 4, 5, 2, 7. Okay, so but I know there's an optimization we can make. I know there's an optimization we can make in there, but I really, okay, 80.26. Maybe that was just a fluke. Although I think the first two that we ran were both faster. 84.47. Okay, that's looking more consistent. Let's keep going here. 80. Okay, so I think this one is faster. Now, there's a lot of duplication here, right? There's something. What is it that we always do? We always do this piece right here. So we definitely, the only thing that changes is this piece. So we can remove this and remove this and put this at the end. I think that should work because we're always going to be incrementing that. That's like what we noticed, right? And then here, if index, can I just combine this like while index, and I might be able to just combine this in a single. I might be able to just do this while index modulo 2 is equal to 1 and, right, we could probably just do this. I think I could just combine these and then I can just do that. This should just be 0 and 0 runner plus plus. Let's see if this works. I'm doing the test case first. 4, 5, 2, 7, 2, 3. Okay. Okay, cool. So let's also remove all this stuff. This is just like cleanup time. Now in here, let's see. What is it? We could make this even better, right? Like here, we could say const parity check parity could return this, and then where the 0 is, we'll just have the parity, right? And then I can say while parity check of 0 runner plus plus. I'm really just moving things around. I mean, at the end it's still going to be I'm just trying to see how condensed I can make it here. Let me run this. 452723. Okay, so we condensed it down a lot. This question was really, really great. I really like this question, and I wish that I would even, man, I know I couldn't have solved this. There's no way I could have solved this even like a couple of months ago. Like I really hope that, for the people watching, like we're just over the top of the hour, so let me just have like a 1-minute spiel thing over here real quick. Like if you go here, you can find all the playlists, all the videos that I've done. You can start from this first one that we did 2 weeks ago, LeetCode accountability stream, and you can start from day one. And the funny thing is, if you start from day one, you'll notice like how things have changed. I used to have like this white background. You'll notice that the mic, like I didn't have a mic. I was just using my headset, which is like really bad. And I think like it's literally question 0, like question 0, man. We were there. So if you can just commit to an hour a day, just watch these streams for an hour a day, or a little over an hour. Sometimes like this one was half an hour, very, very short. If you just commit to that, I think you'll be where I am now with the understanding. So that's really what I'm hoping to do here. Let me just answer some questions here. So I will attempt this later in Python. That's awesome. Please let me know. Like, I would love to hear, like, for anyone that's going to try this out later, comment on the video. Let me know how you did, because I would love to start a conversation with you so we can, like, sort of talk about things and see. Maybe you find a really cool way of doing it. You teach me something, and then, I'll give you a shout out, like, on one of the streams. I'll say, hey, Minaj, like, taught me this really cool thing, so let's, like, show it off for everyone. I started programming professionally 5 years ago. LeetCode has been an ongoing battle because I have bought so many premium subscriptions here and there trying to get better, but the hardest thing was the consistency. So like I finally just buckled down and I'm like, you know what, I'm really gonna like try to just get as good as this as I can, which funny enough, I feel like nowadays, because of my years of experience, I need to focus more on system design, truth be told. But and actually that's something I'm thinking of doing with this channel. Like there's so much LeetCode content, I want to focus on LeetCode, but at some point I would also like to start doing like system design live and have similar live streams where I'm just going over system design. So yeah, hopefully that answers that question. It's been fun. This is unlike anything you do in the real world. I don't do this stuff in my day-to-day job. I'm like a front-end developer. Many times I don't deal with this. I will say though, however, I have definitely made suggestions on PRs based on things I've learned on LeetCode. Like there are absolutely times where I have been able to help someone come up with like a constant time solution versus a linear or quadratic to linear because of a pattern I knew of on LeetCode. So it does help. And it's true what they say, like when you're talking like enterprise level and you're dealing with like microservices that are handling, thousands, tens of thousands, hundreds of thousands of requests, doing things that you learn on LeetCode could really help. Like I remember a colleague of mine changed the way one of these internal microservices worked to leverage hash tables, and he was able to drastically reduce the latency of the service because of something he learned on LeetCode. So it's very cool. I'm gonna go for a little longer because it's Friday. I don't work tomorrow, so I'm gonna see if maybe we can do like 2 more questions. I think doing like 5 a day is pretty good. Does teach some patterns, think about being optimized. Yeah, it really does. It really does. And there used to be like, let me see, Facebook interview. It was like Bumble or something. Beach bum, sun bum. Bumble, Facebook interview. The Daily Show, content. There was like this really cool how to ace Facebook interview. I don't know. Interviewing, Medium, got an offer. There was someone that made a cool article like Bimby or Bumble. Anyway, he said the same thing though. Like doing LeetCode, you get to go back to work and you actually can use some of the patterns that you learn. All right, cool. Let's see this next one. So given an n by n matrix, actually, let me get some water. Return all lucky numbers in the matrix in any order. A lucky number is an element of the matrix such that it's the minimum element in its row and the maximum in its column. Okay. So I think I have an idea of how to do this, only because there's another question. I think it's a medium question that's sort of the same. I think what we should do is, let's think about this. So let me just copy this whole thing out, right? I think we should process this. And maybe you can do it in place. Maybe you don't even, maybe you can do it as you go through the array, but like how would I know? No, you know what? We could do it in its place. We could do it in place rather. Minimum element in this row, oh, and its maximum in its column. No, I think we'll need to, yeah. Because what I'm thinking about doing is just literally going through all my rows and calculating all the minimums, and then going through all my maxes, all my columns, calculating all their maxes, and then just going like that. I think that would work. Right? Like if I had a, because it wants minimum in its row. Let's say we had like min rows, and here we had 0, 1, and 2, where 0 represented row 0. We can just go through 3, 7, 8, and we figure out, okay, the minimum is 3, here 9, 11, 13. Wait, is this sorted? Or is it just 8? Okay, no. Okay, it's just a coincidence that it's sorted here. Here it's 9, here it's 15. And then we get max calls, right, of column 0, column 1, column 2. And then we do, let's see, max of columns. We get the max column here, right, which is 15. This is 16, and this is 17. So I think at the end, 0, the row, and its column. Do we just want to find numbers that exist? Is it just the intersection of both of these? 7, 8, 1, 2. Let me just make sure for 7, 8, and 1, 2. Let's see, on row 1 I'll have 7, and then here I'll have 1. And then that first column will have the max being 7, and the second one will have the max being 8. So 7 is the only one that shows up in both. Yeah, I think we can do something like this. And yeah, what would if I'm just gonna go through all my rows, right? And is this a square? No, it's m by n, right? So I'm gonna go through n rows, then I'm gonna go to m columns. And now to figure out we might even be able to do this. Let me go back to the previous example here. Because as I'm constructing this, it would be nice if I said, hey, the max here is 15. Do I have a 15 in here? All the numbers are distinct too. So I think we might be able to do, maybe we can create a set. We can say min rows is equal to, let's see, 3, 9, and 15. And then we go to like the column and we say, okay, the maximum is 15. Is 15 in min rows? Yes, it is. So that could be a lucky number. Here, the maximum is 16. 16 is not in here. Maximum 17. 17 is not in here. Maybe we can do that. I think I want to do that. Let me see if I can do this. So what if we had min row set? I'll make this a new set. What I can do is for let row equals 0, row less than matrix dot length row plus plus. We can get the max. Oh, but am I still gonna have to? Const max will just equal math.max of matrix of row. Right? This math.max can just take in n arguments and give us the max, and then we can just say min. Oh, but this is the minimum, right? We want the min. Math.min of the entire row, and we can say min row set dot add min. And now we need to get our max. So here, what do we want to say? For let row 0, 1, 2. So let me just, I need to go through like 0, 1. Then I want to do 0, 2, and 0, 3, right? To get all those. I think here we would just have to go through all the columns. Yeah. For let row equals 0. Inside of here, we can do for let column equals 0, column less than matrix dot length, column plus plus, and this would be matrix of row dot length, column plus plus. Here, we can set max. Let max is equal to infinity, negative infinity. And here I can say max equals math.max of max or matrix of row column, right? And let's also do const lucky. Now I think once we get our max here, I can say if min row set dot has max, then lucky dot push max. Think we can do that because I would go through this whole column. Max is 15. 15 is included in my min row set, so I add it. Could be this. Return min. Return min. Let me see. So why is min in the for loop? The reason I have min in the for loop here is because for each row, I want to get the min of that row, right? So row will be 0. So math.min of matrix of row 0. Like this is the spread operator, which will essentially just create a comma separated list of values to pass to math.min. I'll get math.min, which will be 3, and I'll add it to my set. Then I'll go to the next row. I'll do the same thing here, and I'll just continue calculating that min value and adding it to my set as I go along. And then at the end, what I'm doing is I'm going through, starting at this row 0, and then column 0, I can calculate the max all the way down. And then just at the end, I check to see if the max of that column is included in the minimum row. I think that could work. Now, minimum row doesn't have an order, so does it need to be in its row and maximum in its column? Yeah, no, I think that's good. Let's see. Return min. This should be return lucky. Let's just see what we get here. Now, is it a lucky number? Return all lucky numbers in any order. So let's do this. Whoa. Okay. Definitely wasn't expecting that. Let's see what we have. Console.log min row set. Let me just make sure we're actually getting what I expect here. Did I not? So 3, 9, 15. Okay. That's good. Row is 0, row less than matrix dot length, row plus plus. For let column 0, call less than matrix length, call plus plus. Max equals math.max of the max or matrix of row column. Okay. If min row set dot has max. So what is max here? Lucky dot push max. 378. Wait, how is that? Let's go through this here. Let's do this again. I'm just trying to draw this out a little bit better so I see this. So we're going to set the max. So for row equals 0, row less than matrix dot length. Okay. For that column equals 0, column less than matrix row dot length, column plus plus. Wait a second. This is not going. No, yeah, this should be fine. Because really I want to do, right, 0, 0, then 0, 1, and 0, 2. But this is not going in the order I think though. This is 0, column is 0, max is math.max of negative infinity, or matrix of 0, 0, which is 3. So now it's 3. Column now equals 1. Matrix dot length. Okay, column, so 0 of 1, is it 3 or, yeah, that's what's happening. This needs to go the other way. Column, this should be column less than matrix dot length, column plus plus. This here should be row less than matrix dot column dot length, but let me see exactly what this does here. Row plus plus. Okay, let's figure this out now. I want this to actually be 0, 0, 0, here, here. This should be as many matrix of column dot length. This should be matrix of column dot length, right? Because I want to go, these all represent columns. Row should be less than matrix dot length, so I can go all the way to the end. So now max will be negative infinity, let row equals 0, so 0, 0, then we go to, this should be column row, even though that sounds weird. Negative infinity or 0, 0, then we go plus 1, 0, 1. Okay, so let's try this out. Let me print out the max here. 0, oh, it doesn't like that I'm doing all this stuff. Let's see what this gives us. What? Matrix column dot length. Is it because column is not yet? Does it not like that? For let column equals 0, call less than matrix dot call dot length, the column that I'm currently on. How else can we represent that? Are they all the same? I mean, will this always, they're all going to be the same, no? I think we can do this. Still nothing. 8, 13, and 17. Max is negative infinity. Matrix of 0. Okay, let's write this one more time. Like, we know our set is right. We definitely know the set is right. It's this part that right here that I'm not getting right. So column is 0. Column is less than matrix of 0 dot length. So what's matrix of 0? I think these will always be the same, right? N equals mat of I dot length. All elements in the matrix are distinct. It's m by n. So they'll always have the same amount of columns. Matrix of 0 dot length is 2. So that's fine. 0, 1, 2. The row should be less than matrix dot length, which is also 2. Okay. Row plus plus. So let's go over this slowly. Column 0, row is 0. We're going to be right here. So max is equal to math.max of negative infinity, right? Or matrix of column and row, 0, 0. So that should be 3. So max should equal 3 in this case. Now we're going to increment row to 1, right? And that's going to be the next thing we check, which is 0, 1. Oh, but that's still not, wait. I'm going about this like completely the wrong way. This should be row. This should be column. There you go. I think that's what it is. It takes a couple. See, this is, again, this is where we get the value, right? Still getting it wrong. Why is that? 15, 16, 17. 3, 7, 8. STD out, 15, 16, 17. What's our min row set here? Console.log min row set. Should be getting the min of each one. Should be 3, 9, 15. And now we're not adding anything to our set. Oh, did I remove that whole thing? Min row set dot add min. Okay. Yeah, no, it is. It is definitely trippy. There you go. Okay, we finally got something that matches the answer. Okay. Let's now go ahead and get all our test cases here. Let's see if my theory was even right. We've only solved one test case. Let me remove that STD out. Because it could be the case that we take a contrived example, 15, 12, 7, 15, 12, 7. Okay, let's go for it. All right, sweet. Love it. I love it. I love it. And 98.6, I mean, I'm pretty happy about that. So, yeah, this piece right here, it's weird. Because you know what? This is a good question because typically, I feel like, you know, we're used to traversing 2D arrays. 2D arrays, you know, normally just like start at the first row, go through all the columns. Next row, go through all the columns. Next row. But here, we're forced to now think of it differently, right? We're traversing this 2D array in a different way. And if we think about time complexity, my JavaScript isn't that strong, so I was a bit lost following along. Yeah, I'm sorry. I know I tend to like go fast sometimes. I try to like explain things as I go along. I do my best. But let's try and think about time complexity here, right? So here we're gonna go through every row and we're gonna go through every column, right? So this is gonna be m by n because m for every row and this min operation here is n for every single element, every single column in that row, right? So this will be O of n plus n right here. And I don't think, are they gonna be, is it a square? Matrix, I don't think it's mat.length and n equals mat.i.length. Yeah, it could be, different sizes. So it'll be O of m by n. And this will be the same thing too. So if it was a square, I know earlier, Minaj, you mentioned O of n. Yeah, I think it would definitely be O of n if it was a square. No, it wouldn't. It would be n squared. It'd be n squared. Funny, I'm messing up time complexity as you say that I'm good, which thank you very much. I do appreciate that. I'm learning right alongside here with you guys, but I do appreciate it. So yeah, here it's O of n by n. If it was a square, it would be O of n squared, because we have to go through the entire array, the entire 2D array twice. Now, let's get to the fun part. Every time I go into discussion, I'm always like, I'm waiting for there to be like a bitwise manipulation solution and me just feel like, oh man, I was so excited. But let's see. 2, 2, 3 passcodes with brief explanation. So one-liner using set intersection, min, max, and met. Okay, so I'm liking the title so far. Feel good. Why we need to fill an array with the max value. This is a lot to read right now. I don't want to read it. We can create a set of the minimum row values to create a set of the maximum column values. We can use the unpacking operator on the matrix and use zip. All right. We can then get a set of our lucky numbers by intersecting those two sets using the intersection operator. So I feel like this is close to like what we did. So I'm happy with that. Let us shoot for one more. Hopefully we'll end off with a nice high quality question. Make array 0 by subtracting equal amounts. Did we? Okay, I thought I had done this question already, but no. How are people doing one lines? Yeah, I know. The thing is, like, okay, so I've said this many times in discussions, like, discussions I feel like are only good when a question is like new. So let me just open up any like random one here. Go to discussions. So like everyone here is going to have an in-place iterative and recursive Java solution. It's mostly a matter of like who got there first. If you got there first, you're going to put a solution. Everyone's going to love it. The thing is though, like the differences between any of one of these solutions is just like how it was written or an explanation, so on and so forth. So you're not really gaining much by reading too many of these. I think you probably got to find the best one and read that one. And then also the one-liners, a lot of these like top solutions are one-line solutions, but you don't learn anything from those. So it's cool, and I'm sure it's gonna impress your interviewer, but it's hard to like just understand. All right, let's make this one our last one. We'll see how good we can do, and then we'll go from there. Thanks so much for you both, like Minaj and Rashawn. Super awesome that you guys came along. I'm really hoping I see more of you guys. And please comment on the video. Let me know your progress. Let me know if there's anything I could help, like even offline, you know? I would love to help. All right, so you're given a non-negative integer array nums. In one operation, you must choose a positive integer x such that x is less than or equal to the smallest non-zero element in nums. Subtract x from every positive element in nums. All right, so I gotta see an example here. First operation, you choose 1 because that's the smallest one. Okay, choose a positive integer x such that x is less than or equal to the smallest non-zero element. Less than or equal. So do we always just pick 1? In the first operation, choose 1. Now we subtract 1 from all of them, okay? Then we choose 2. We subtract 2 from all of them, and now we get to 0. Okay, 0, 0. Interesting. Ooh, man, this is cool because even on page 2 of Easies, we're starting to get to some like interesting questions. How do we go about doing this one? 15035. Let's see. So like when I think about minimum maximum numbers, I might almost think of like a heap, but the thing is this is going to be changing every time, right? This is going to be changing every single time. Like we pick the minimum one and we subtract. I mean, we can simulate this. We can simulate this pretty easily, but it's not going to be efficient. And it will be, okay, it will be 0. Every element in nums. Yeah, I can do something that's super brute forcey, but it's not gonna be nice, right? Like think about the steps. 1, while not every element in nums is 0. 2, pick min. And then 3, subtract min from nums. So it's not gonna look good. Oh, and then make array minimum number of operations to make. Okay, so let's say let operations equals 0. Wow, and I'm gonna use some JavaScript here. I'm gonna try to explain this one, Minaj. So in JavaScript, there's a cool method called every. What every does is it tests all of the elements in your array to see if they pass a certain function, right? So you pass in a function to every, and then that function is run for every single element. And if that function is false, let's say it like returns false for the second one, every immediately terminates. So it doesn't even go through the whole array. It will only ever make it to the end if it's true for all of them. So what I want to do, right? What is it that we want to do? We want to say while not every element in nums is equal to 0. So I can say while not nums.every num equal to 0, right? Because like if nums.every num is equal to 0, return true, then I know we're done, right? But this is while it's not this, we can get the min. So I can say const min equals math.min of nums, and then now we can map. Again, I'm sort of changing like, but we can do nums equals nums.map. We take the num, right, and we just do num minus min. Now we get back an array that we subtract min from every single thing, and we keep checking that. And we do operations plus plus return operations. I am 100% sure, like if this runs fast, I'm just gonna I'm gonna go crazy. But let's see what this gives us. It might, wow, are we gonna get time limit executed? Not executed. Exceeded, time limit executed. Or is this, maybe I'm just running, I might be getting into, okay, but is this time limit exceeded because, let's see, nums.every, all not, so nums.every nums is equal to nums.map. You take the num and you do num minus min. Choose x equal to 1. Now oh, okay. It can't be 0, right? Obviously, it can't be 0. So math.min. Oh, and that makes it even trickier because it can't be 0. Like math.min will just pick 0. So how do we? Oh man, we can make this like really nasty. We can make this really, really nasty where we say get the min of nums, where we filter num. If it passes the test case, it's included. Num not equal to 0. Oh my god, this looks nasty. Will this make it run? Like I can't tell if it's not running because the while loop's not ending. So, oh, but I also don't want to filter because that's going to make the size of my array smaller. Let's think about this. You know what though? You know what we could do? Let's forget all this shenanigans because this, you develop code smells, and this is, I'm detecting this is a foul smell here. You mentioned a while ago, Minaj, sorting. What if we sorted here? Right? 0, 1, 3, 0, 1, 3, 5, and 5. Could this help me? Because maybe all I need to do, like I can pick, let's see, I can sort it and I can find my first, okay, so let's do 1, sort array, and then 2, find first non-zero element. Okay, so we sorted the array, find the first non-zero, which is here, right? Index. This is going to be my min. So now maybe what I can do is I can say from the end to non-zero element, subtract nums of non-zero element, if that makes any sense. Right? So we sorted the array. Now we find the first non-zero element, which is here. And now we can start from the end and go to where we found the non-zero and go all the way to the end. And then at the end, we check to see if I is not 0, right? So like we start subtracting, this is 4, this is 4, this is 2, this is 0. Because I is 0 now, we increment this and do the same thing. Now 2 is our minimum. So I think we can, this could be something that we can try. This could be something that we can try here. So let me see. Let me sort the array. So let's say const sorted. Something else I'm going to do here, Minaj, just so you can see. So I'm gonna copy our input nums because I don't want to actually alter nums. I want to create a copy of it. That way, if anyone uses this function, then nums will not be modified. And here we're going to sort it in AB, A minus B. And then I'll say const first non-zero, or let's just say const index. We could do sorted dot, and I think does index of, I think index of takes a callback, or does it not? No. Find index. Okay, find index is the one that takes a callback. So can I do sorted dot find index of num where num is not equal to 0. So let me see. Let me just make sure. I want to verify that here index should be 1, right? Because 1 used to be a 1 there. Let me see. Okay, std out is 1, so that's good. Now I could probably do the same thing. Or actually, no, all we need to do now, let's make this let index, right? Like by the time index is out of bounds, right? So check this out. Let's start again, right? So imagine this is 0 and 1. Let me uncomment this. So we find the first non-zero index here. Let's put this back, right? So now we start from the end and we start going down. So we say 4, 4, 2, 0. So I is 0, so increment. Now I is 2, do the same thing. 2, 2, 0. I is 0, increment. We do the same thing. 0, 0. And then we just increment. And then so we could do this while I is in bounds. So while index is less than sorted dot length. So let's try this out, right? While index is less than sorted dot length, we can just now do for let I equals to sorted dot length minus 1, I greater than or equal to index I minus minus. We'll do sorted of I minus equals sorted at index. So let's go over this. So let index, it was 1 to begin with, right? So let me actually just sort this again. So we had 1, 5, 0, 3, 5. So here it's that, a 3, a 5, and a 5. We start with index here. That's like our starting position. While index is less than sorted dot length, okay? For let I equals sorted dot length, so we'll start here. I greater than or equal to index, which is here. I minus minus, so we do sorted of I minus equals sorted of index, which is 1. So we'll do this. We'll decrement, we'll do 1. We'll decrement, we'll do 2. Decrement, 0. Okay, and now we should actually say if, I guess, I wonder if I can break out early. Since if I'm sorted and the next one is already 0, maybe I can just break. So maybe I'm gonna try to do if sorted. Let me think about this. Let's do the optimization later, since we know that optimization is sometimes we get caught up in optimization, right? So here we can say while sorted of index is equal to 0, we can say index plus plus. But we can also say while sorted index is equal to 0, and we should also say index less than sorted dot length. Yes, I definitely will. Which one? The first one or the second one? This is awesome. Like I love that like it's as interactive as it is right now. That's awesome. Let me just kind of, yeah, so what is it that I'm doing here? Let me start again at the beginning, right? So we started off with sorting our array. So we get 1, 5, 0, 3, 5. So I sort this and it becomes 1 or 0, 1, 3, 5, and 5. So that's what this sorted piece right here tells me. Now this index, so what am I saying? I'm saying in that sorted array, I want to find the index of the first number that's not equal to 0, because we don't need to consider zeros, right? Because they're already 0, so we just need to find the first non-zero one. And that first non-zero one is this 1 right here, so that's where we're going to put our index. And now, while index is less than sorted.length, because at some point, like every time one of these becomes a 0, I'm going to increment this. And at some point, it's just going to exceed the bounds of the array because all these have already been made 0. So let's sort of go through this piece here. While index is less than sorted.length, right? What I want to do is using this number, which is the minimum, I want to start from the end And I mean, I can start from the end or actually just go from here all the way. I don't need to start at the end actually. Now that I'm thinking about it, let me see. Let index equals sorted. And then I also wonder if we can do, yeah, maybe to make it a little bit easier, I can say let min equals sorted at index, right? Because the minimum will be where the current index is right now. Then really what I can do is I can just say for let I equals index, I less than sorted dot length, I plus plus, I can say sorted of I minus equals to min. Right, so let's think about this. I find the min, which is here, and now I say starting at this I, which is index, all the way onto the end, I'm just going to subtract min from each one of these. So I get this is 0, this is 2, this is 4, and this is 4, right? Because the min was 1. Now I get to the next part. Now index here is already 0, so I need to like increment this to the next one so that 2 becomes my new min, and I start doing the subtraction again. So this while loop in the bottom, I was going to say, while index is less than sorted dot length, which it is, and sorted at index equals 0, index plus plus. So now, and I think this first piece right here will make more sense in a bit. But the reason I'm doing this is because I want to increment it until I find the next min that's not 0. I increment my index. Now we get to the next piece. Index is less than sorted length. My min is 2. So now starting from here until the end, I subtract 2. This is 0, this is 2, and this is 2. Index is less than sorted length, and sorted index is 0, so I increment index, go to the next loop again, right? Because now it's 2. So this is going to evaluate to false, and it will make the whole statement false, so I don't do this while loop. I get to the next piece now. Index less than sorted length, my minimum is 2. I start from here to the end, I start subtracting 0 and 0. Right? So check this out though. Now they're all 0, but like I need, like my I can keep going indefinitely, right? If I remove this condition while sorted index is 0, it's going to be like, okay, it's 0, so let me go. Okay, it's 0, so let me go. Now it's going to come over here, and I'm like trying to access an out of bounds index, so it's going to throw. So really, I should also make sure that index is less than sorted dot length. So I'll get over here, I'll be like index plus plus, this is 0, this is 0. I come out of here, let index, right? Index is no longer less than sorted dot length, so we're done. So what we should do now is we can have let operations equals 0. Anytime one of these finishes, operations plus plus, and return operations. And let's see what this gives us. Let me remove all this. Long stream today. Okay, 3 and 3. The second example is very contrived, so. And look at this. It looks, we are actually running into an edge case here. Because how do we know? So index, we sorted this one. Let operations is 0. While index is less than sorted dot length. Oh, did we ever find index? -1 is returned. So here we should check to see if index is -1, then we can just return 0, right? Because it's already, right? Like if index is -1, that means we never found the number that was not 0. So everything is 0. So we can just return 0, no operations done. Good test case to run into. 3-0. Let's run this and let's see what happens. 95.77. I'm like, for some reason I'm skeptical because I'm thinking like, how is this running that quickly? Like I think I've just been looking today with LeetCode. Normally it doesn't run that fast. But hey, like I'm gonna take it. Let's see if we can think of the time complexity. I mean, this is constantly in the 90s here. So the time complexity, like for sure, it might, this, you know what, this might be, because here we have a sorting, which is n log n. Here we have a find index, which is n. operations while index is less than sorted.length. Like this will happen n times in worst case. But right now, this piece right here for let I index I less than sorted.length, like I'm going through every single one of my, I'm going through everything. I'm having to go through every single thing. Is there ever a moment where I know after I do one of these, if my index to my right is 0? I think something that we can do, index, what if we say if index is less than sorted.length minus 1 and sorted at index plus 1 equals 0, return operations. I know this looks crazy. This might just be like a minute optimization, and let's see if it even runs. So what I'm doing here is like, if my array is sorted and my next position is already 0, then that means everything else should be 0 already. I think so. Am I hurting my acceptance rate by doing this? We're gonna go for it. Okay. Oh. Runtime error. I think in all honesty, this is a quadratic solution that I have right now. And look at that. That actually even, yeah, let me see. Number of different positives, a set. Oh, I gotta see this. Look at that. This person did it in linear time. Let's see what we can do here. Same elements are always the same, okay? Different elements are always different until 0. Return the number of different positive elements. God, this is amazing. Set.size. Like this, okay. Code looks easy and simple. How do you come up with that intuition? Is there anyone? Set using sort, simple and beginner's approach. Subtraction. So we sort it for count the total. If num's greater than I, subtract the current value from those. Here's my approach for sort and count. You see, so like some people here will say, oh, you know, we can simply just calculate different positive. But I mean, the odds that this person came up with a novel solution, it could very well be that they're the ones that came up with it, but most likely they're just sort of regurgitating what this person said. So a lot of this is just like trying to piggyback off of someone else's success. Yeah, this one's interesting here. Brute force. So yeah, we did it in the brute force way. Optimal. This is, okay, yeah, it's optimal, but it's not easy. It's not easy to figure out. I'm not even sure why the same elements are always the same when you subtract them. The different elements are always different until they're 0. So you just count the amount of different non-zero elements. So you have 1, okay, you have 3. Here you have 0. That's wild. That's crazy. So I can just do const set equals new set nums dot for each num if num not equal to 0 set dot add num return set dot size. Sheesh. That's crazy. Like, I mean, that's cool. This is one of those, like, probably feels so bad because how do you come up with this? How do you know? How do you know that? I don't know. Anyway, Man, this might be my longest stream to date. Almost 2 hours of doing LeetCode live with Minaj and Rashawn. Let's see. I think, yeah, we did 5 questions, right? So we're going to be sitting at 135 now. Yeah, buddy. All right, cool. Yeah, I had a lot of fun doing this today. I'm getting hungry, so now is about the time to stop. This was awesome. One of the best streams I've done to date for sure. I feel like we learned a lot. Hopefully you all also feel like you learned a lot. If you like what you saw, if you made it to the end, I know it's long, but I'm really hoping you can think of this as like a podcast, just like you might watch Joe Rogan or I don't know, Sam Harris or something like this. Hopefully you feel like this is entertaining and it's beneficial for you in your journey. So if you liked it, make sure you subscribe. Tell your friends about the channel. Let's grow it. I'm trying to get to, like, my next goal that I really want to get to is to hit 500 subscribers, because that's going to allow for me to take part in the community feature. And the cool thing about the community feature is I can start like interacting with you all, start asking questions. We can maybe talk about like the daily question. We can just talk about other ways to improve the channel. We can all get better together. So subscribe if you like it. Tell your friends about it. Ring that notification bell so you get notified of the next time I go live. I'm going to be live again tomorrow, a little bit earlier. I'm on Eastern time. Tomorrow we're going to do our weekly roundup that we have down here. So weekly summaries of previously streamed content. This is just me going back and looking at questions that we weren't able to solve the first time and just seeing if we can this time based on the stuff that we've learned. So I'll share it with the other devs who are learning on Discord. That's awesome. By the way, if you're not, I don't know what Discord you're on. Apologies if you joined my Discord, but definitely share it with your friends on Discord. That'd be awesome. If you look at the bottom, of any one of the streams, you'll also notice a link to the Discord that I have. I've been running this Discord since December. I think we're past 1,250 members. That's been a lot of fun, and I sort of like grew this based on that user base. But yeah, share it with them and let's just get more people. Again, thank you all so much for joining. Really appreciate you all being here, and stay tuned for tomorrow's weekly roundup where we'll do more fun stuff like this. Happy coding. Have a great Friday, and we'll see you all next time. Take it easy. Later.